Hi, Jen. Sorry, I kicked myself out. Yeah, I can hear you.
Ah, great, thanks. Okay, I guess we can start. Welcome to the Operational Security Working Group. Ron, who is my co-chair, cannot be with us today, even online, so please bear with me as I'll be alone, clicking all the buttons I need to click. First of all, this is not well. I believe it's not the first time you see it. If for some reason it's the first, please look at the slides and read it well. Yes, before we start, anyone is willing to take meeting minutes, please? You see we have transcription, so all you need to do is basically copy and paste.
Jen, yeah, happy to help with minutes. Is there anything else to help with if you're chairing on your own?
Oh, no, I say thank you very much. I think I'll be good.
Okay.
Be okay. Yeah, just thank you. Thank you for taking minutes. Okay, just reminders. Well, in person, I usually ask people to use on-site tool to join the queue because it's much easier for chairs to control just one queue. Because when some people join queue virtually, some people just walk to the mic. It's really hard to keep track of who was the first. Obviously, please state your name when you're asking questions so we know who is speaking, so your name can be recorded in the meeting minutes, and online participants also know who you are. Please wear masks unless you're actively speaking. If you are remote, please keep your audio and video off until you're presenting or talking. And by the way, a few IETFs ago, I discovered the great feature that some phones can remember that on this particular SSID, they should stay on silent mode. Great thing at IETF. So I suggest you put your phones into vibration or silent mode, so you're not interrupting speakers. We didn't meet in London because we did not really get much of the agenda. So what's happened meantime? So we published an RFC, recommendation on filtering on extension headers. Congratulations to the authors. Indicators of compromise draft is currently with RFC editors queue, almost ready. We just moved out of working group last call for attribution of internet probes, which was presented, I think, on the last meeting or 2 meetings ago. I just need to finish the write-up and it will be advanced. Thank you for everyone who commented on this, as the draft was in the last call a bit longer than expected because we wanted people actually to review it. Agenda, we have 2 presentations today. Fernanda will tell us about implications of addresses, IPv6 addresses more specifically, on security operations. And the second presentations from Andrew will be about encrypted client hello deployment considerations. I guess that's all for the chair slide. Any last minute agenda Bashan suggestions? You want to present something? Nobody? Okay, good. So, Fernanda, the floor is yours. Do you want to present or you want me to move the slides for you?
Let's try. It's not going to work, but let's try. Why not? If I can present on myself. Can you see my screen? Or do you get a request?
Just a second. I think wait. Why? Okay, hold on.
Yeah.
I, for some reason, do not see a request from you to share the slides.
Oh,
Can you?
Okay, so let me cancel and send again. Let's see. So I send the request again.
Okay. Why? You know what? For some reason, I see
Okay,
the
let me
request.
see this one. Ask to share slides. Let's see if this one, I don't know if, do you get something? Otherwise, you can share it because
Yeah, okay,
it's
let
like,
me share it. Just
yeah.
for some reason, I do not see it. Okay. Okay. New slide deck. Okay, here we are. Floor is yours.
That's cool. That's cool. So good afternoon or good morning, depending on where you are. I'm Fernando Gont, and I will be presenting this document, Implications of IPv6 Addressing on Security Operations. Next slide. So I will start with a brief discussion, two things. Like, first of all, try to essentially describe or discuss the motivation of this document, which is one thing, why we ended up writing this document in the first place. And then in the introduction, also provide some context information, which is super useful to actually go and discuss the rest of the topics in this document. Next slide. So we know that the main difference, or one of the main difference when it comes to IPv6, is obviously the address space, and these differences in the IPv6 addressing with respect to IPv4 have like concrete implications on security operations. This is normally like well known in IPv6 circles, if you want to, if there's such a thing, like groups like ours. But these implications are usually non-obvious to other groups. And when I'm saying other groups, that could be like cloud operation groups, DevOps groups, security operation groups, and so on. Now, what happens with this group is that quite often they assume that, well, there are these IPv6 addresses, they look different, they are longer, but for the most part, they assume that they must be the same, just longer addresses, right? So these groups try to apply IPv4 policies, or IPv4 like concepts when doing IPv6 security operations, and that's when things normally fail, or there are like gotchas or surprises in there. So this group was actually motivated by conversations with these kind of groups. I was involved quite a few times, whether for companies that I was working for or companies that I was consulting for. And for me, the thing was that we were into conversations, and there were a lot of things that I assumed that were obvious to everyone, but well, that wasn't really the case. So that's when we came up with this idea of trying to discuss this topic, because we thought that discussing this topic, documenting things, let's say the challenges and possible ways to address those challenges, might be of use to other groups. Next slide. So one of the things that I mentioned in the previous slide was differences when it comes to IPv6 addressing when compared to IPv4. I mean, obviously the address length, that's obvious, but you might wonder, what other things, I was thinking of. And there are a few things in there. Obviously, we are talking about the ones that, probably will have implications on security operations, which is the topic under discussion. So one of these differences has to do with the properties of the associated addresses. And there's a bunch of properties associated with each IPv6 address. For example, there's the address scope, whether the address is local, link local, ULA, whatever. There's the stability property, which, for example, you might have stable addresses and temporary addresses, just to name like the two extreme cases, if you wish. And there's the intended usage property, this is normally not explicit, but at the end of the day, for example, in cases where you have stable addresses and temporary addresses, well, there is an intended usage for each of them, like stable for incoming communications and temporary addresses for outgoing communications. So that's when it comes to address properties, but there are other things. Like we all know that, IPv6 nodes, particularly, IPv6 hosts, they configure multiple addresses at the same time, something that is like not, it's unexpected for people coming from, with just IPv4 knowledge. And not just that, like the addresses that, are configured actually have different combinations of the properties that I just mentioned. So you might have the same host might have like, one, global and stable address, one global and temporary address, one link local stable addresses, etc., etc. So many addresses with multiple different combinations of these properties. Another thing that is interesting is that we all know that there are multiple ways to configure IPv6 addresses. And for example, when it comes to the automatic mechanisms, the HCP and SLAAC, normally the mechanism that you use to configure the addresses ends up having an effect on the actual properties of the addresses. Let me give a super straightforward example. If you have a workstation with Ubuntu and you attach that workstation to an IPv6 network that does SLAAC, Ubuntu will configure stable and temporary addresses. But for the most part, or in most cases, if you attach the same workstation to a network that does the HCP version 6, since temporary addresses for the HCP version 6 are not widely supported, then for the most part you will get just stable addresses. So the mechanism that you use to configure the addresses ends up having implication on, or ends up defining in some way the properties of the addresses that eventually you get. And another thing that is like super important for this topic is that in most of the cases, like users, like IPv6 users or attackers, for instance, they have control of a large IPv6 address block. Compare this to IPv4, where if you are like super lucky, you might get like one public IPv4 address at home, if you're lucky, right? Sometimes not even. But with IPv6, it's usually the case that at the very least, you get at least a /64. So the user or the attacker controls like a large address block. Next slide. Now, key and super related to what I've just discussed, and this is normally the case for people doing security operations, is what's behind an IPv6 prefix, or what's the semantics, if you wish, of an IPv6 prefix. And here I'm using the term, prefix in a super general way. So it could be like a /128, meaning a single IPv6 address, or a /64, like a proper prefix, if you wish. So few things to consider here, because obviously this will affect the rest of the discussion. First of all, it's super common that multiple addresses map to a single host. And this is because, as we were discussing before, hosts normally configure multiple addresses, okay? These addresses are normally selected from, from the same /64, assuming that the host is connected to a single network. But for example, if it's an advanced user or if it was an attacker, you may assume that actually they may be selected from a larger address block. Like, for example, the user or the attacker could get a whole /48 from the ISP, or even if the user doesn't get a /48, the user might apply, for example, to a free account at tunnelbroker.net and get a /48. So that the user or the attacker could potentially select addresses from a /48. Obviously, this is different from the IPv4 case, whereas if you're lucky, normally you just control a single address, unless you have like, you control multiple VMs or whatever that is. But from a single place, you just control a single address, if anything. Now, also, there's like, there's a different aspect that while in theory, you normally associate one IPv6 address with a single network interface. That's the theory, at least. Now, in practice, NAT-PT or NAT for IPv6 is not uncommon. Whether we like it or not, that's a different question, but it's not uncommon, okay? And there are technologies like, if you have been, playing with Kubernetes, for example, when you do, IPv6 in Kubernetes, normally what happens is that you use ULAs, like, IPv6 private space, so to speak, a combination of that and NATs. So NATs are not uncommon for IPv6. So all of these aspects are going to be key, like stuff in this slide and in the previous slide are going to be key when we discuss like different aspects of security operations, if you wish. Next slide. So these are three topics that we are going to briefly discuss. Obviously, this is a non-exhaustive list at all, but this is just three topics just to see how in stuff that is super simple and super straightforward in IPv4 and people who do things in a certain way in IPv4, in IPv6 things are different, or you might run into surprises, or maybe you obviously, but normally people that come with an IPv4 only background, they run into surprises. So we will cover two areas. One of them is enforcing ACLs. Like allow list on one hand and block list on the other hand. And then we will also cover a little bit the area of network activity correlation, essentially trying to analyze the relationship between different network activities. Okay, so next slide. And next slide too. So the first thing that we'll do is essentially we will try to cover or at least discuss a little bit the challenges in each of these areas. And then after that, what we'll try to do is to shed some light, or not even shed some light, like, try to brainstorm a little bit what are some of the things that, you might possibly want to do in these cases. So the first of the topics that we discussed before was the use of ACLs, access control lists, and in particular, allow lists. Normally, obviously, what you want here is that you want a specific system to be allowed access to some resource, and in a way, you want to have just an ACL that allows that system and not any other system. Now, one of the obvious challenges that people find when using IPv6 is that if you have a network where the hosts are using temporary addresses, by definition, these hosts are going to be changing the addresses all the time. That's by definition. That's what temporary addresses are. So, the addresses change all the time, but also if you have multiple systems on the same subnet, which is normally the case, not only the addresses will change, but the temporary addresses of these systems will be intermingled in that /64. Like all of them are changing the addresses, and all of them pick addresses from the same /64. Now, the question is, if you want to, let's say, implement or enforce this kind of ACL, what would you allow? What's the ACL that you would configure? Now, people with an IPv4 background have the tendency to say, well, in IPv4, normally I would allow /32, like a single IPv4 address. So if in IPv6 the addresses are /128 bits, then let's allow a /128. And obviously, if you have temporary addresses in place, these ACLs will change. Like whatever address you find at some moment in time is going to be different later. So your ACL, your allow list will fail if you do things that way. Next slide. Then the other topic is block list. And normally, obviously, we're not discussing whether, this is, good to have or not. We are just saying that these things are done in practice. And these are the challenges that, you will probably find when you try to, these on IPv6. So what about block list? Depending on the, the environment and the scenarios, normally what you might have is some sort of tool that can feed you with addresses that are known to be engaged in some sort of malicious activity. For example, you have you could be using some CM IPS platform that, obviously it's monitoring security login events. And, when this system, for example, finds that, there's a port scan from a specific system, or, a number of failed attempts from some address, it might give you the option to actually enforce an ACL based on that offending address. There are also other tools which do or allow you to do, same kind of stuff, like fail to ban, for example, local tool that you run on a system. It just scans, the logs. And for example, you can configure fail to ban such that, I don't know, if a user or there's more than 3 attempts to, SSH into the system and they fail, you just block that address. So there's a lot of things that you could do. But so you have sources of that, different sources that might provide information about, addresses engaging in, in malicious activity, for example. Now, the question here is that these tools will normally give you a /128, like a single address, similar to what happens in, in the IPv4 world. Now, the question is, well, what should we block? So, okay, we learned a full IPv6 address /128. What should we block? Now, this is tricky. So if you come from, or if you approach this topic from an IPv4 perspective, obviously what you do is you just block the /128. But that's tricky for 2 reasons. One of them is that, since the attacker controls a large address block, the attacker could intentionally trigger, the generation or the enforcement of a lot of, wasteful ACLs, just because the attacker can use the whole address space. So that's one thing. So you have to be careful about that. That's one thing. Second thing is that obviously, since the attacker controls a large part of the address space, the attacker could use the throwaway addresses, meaning that you may craft, for example, a script, and you configure an address, for example, do an attack attempt, and right after that, you just configure a different address, so the next attempt uses a different address. So if the folks on the defendant side are just going, first of all, probably they will see a single attempt, so they will not get to block anything. But even if they got to block something, then you just switch to a different address and you continue your activities. Obviously, doing this in IPv4, based on the IPv4 address scarcity, is way, way more difficult. At least you couldn't do this like even from home. Okay, you have to have like zombie systems or rent VMs or whatever, but you wouldn't be able to do this as easily as you can in IPv6. Next slide. Network activity correlation, well, for the same reasons, is like non-trivial exercise, because based on what we discussed before, essentially you could have like either multiple systems behind a single address, behind a /128, or actually you could have like the same node that is moving around all around a /48. So the topic is tricky, or at least non-trivial. So these are the challenges when doing these three things: allow list, block list, and network activity correlation. Next slide. So now it's like more than advice, I would say this is like brainstorming, even not my own in a lot of cases. These are things that I either did myself, or that while discussing with document, either on the OPSEC mailing list or on other lists, we discussed the topic, and these are the ideas that we came up with, essentially. So next slide, please. So what can you do when it comes to ACLs? Well, the solution here is kind of like obvious. Either, option one, you have to use stable addresses. So if you have like multiple systems on on the same subnet, you'd have to find a way to configure stable addresses. There are multiple options for that. Could be manual configuration. It could be some form of the DHCP version 6, or could also be Slack if you are using, for example, stable addresses 7217, and you disable temporary addresses. Now, if you get to do that, if you get to do stable addresses one way or another, then that's the way the addresses stay, and you can enforce the ACLs by specifying /128. The other option is that if for some reason you can't have systems, do stable addresses, or you want these systems to do temporary addresses for whatever reasons, then you don't have much more of an option, if you want to enforce ACLs, that to segregate them into different subnets and then specify the ACL as a /64. Because that's the prefix that these systems will use, and they will be changing, each system will be changing its addresses within that /64. I mean, not necessarily nice, but it is what it is, right? Next slide, please. So we cover allow list. So what about block list? So we were saying before that normally you have some source of information for addresses that you might want to block, and the potential problem here is that you might end up, getting a lot of addresses that you might want to include, or you might be tempted to include in a block list. So what you probably want to do is to keep an eye on that and be able to aggregate these addresses. And obviously, as you aggregate addresses into, let's say, ACLs that use shorter prefixes, obviously you may want to, or you probably want to change the lifetime of those ACLs. Next slide, please. So this is something we discussed this on, in one of the mailing lists in which we discussed this document. This is definitely, this is more brainstorming more than a recommendation. And when you look at the values, these are just values to have a number to refer to. We are not pretending or expecting that these numbers are good, or even good enough. So the basic idea is that you might say, okay, well, I'm going to have like different levels of aggregation. Let's call it level 1, 2, 3, and 4. Whereas in level 1, you specify the ACLs as /128, in level 2, /64, level 3, /56, and level 4, /48. And the basic idea is that, whenever any of these tools give you an offending address, what you do is you configure an ACL as a /128. And if you keep this ACL for, let's say, an hour. This is common for many of the tools that we have discussed. Now, if eventually at some point you are able to aggregate, say, for this case, 10 different addresses, 10 different /28s into the same /64, then what you do is obviously you aggregate those addresses, you remove the individual /128 into a single, /64. Then you might run into the same thing. Like, for example, if it's the same attacker moving over the address space. So you might have multiple /64s, the result of aggregating /128s. And if eventually there's, for example, 10 of these /64s that you can aggregate in the /56, then you do that. This is a way of, reducing the number of, entries that you might have in your block list. Obviously, this doesn't come for free. Obviously, as you aggregate the addresses, there's like the side effect or the potential of, or the possible side effect is going to be larger. So, you have to be careful with this. And you might want to say that, well, I will just aggregate till /64 or maybe till /56, but not get to a /48. Next slide, please. And for network activity correlation, the topic is way more complex, but the basic thing that we say is that quite often, when you look at security tools, many of them, they just assume that, let's say, the identity of an actor is an IPv4 address. So for the IPv6 case, at the very least, what we expect that these tools should provide is like, right away, the ability that you can select in the tool, what's the prefix that identifies, or the prefix that potentially identifies the actor. So that, for example, if you assume that the attacker controls like a /64, then anything that falls into that /64 is considered to be, an activity from the same actor. This is obviously just scratching the surface, so to speak. Next slide, please. And next slide. Too. So this is it for the document. So what we are awaiting is what we are interested is on the one hand whether there's comments, feedback from the working group, and depending on that, if there's interest to work on this as authors, of course.
Okay, I put myself in the queue while people are logging into on-site tool to get themselves in the queue. First of all, thank you very much, Fernanda. Interesting and perfect timing because, well, shameless plug, you might know that in v6 ops there is currently a draft, which in the next revision will have another benefit added to the text, that if you're using /64 per host, your ACL creation becomes much easier because you do not really care what addresses the particular host is using. You can just add all of them in the ACL, and your ACL might become slightly better for hardware because like TCOM is expensive.
I read on that.
Yeah, cool. So, and few minor comments. You when you're saying that multiple hosts might be hiding behind one address, I don't think it's something new, something v6 specific. We're getting the same for v4, right? You plug in something into the network, you don't really know what is behind it. So I'm just to be honest, my impression is this document should probably contain something which is specific to v4 and clearly states this, and maybe things which are the same as in v4 shall be also marked as it's not something new, it just, we're basically getting the same in v4.
Yeah, agreed on that. So yeah, 100% in agreement. So the thing here is that, I mean, most likely everyone that is in the meeting know about that. But, for people that, don't follow the v6 topic closely, they expect that, okay, well, IPv6, it's all about addresses. So there's no NAT, right? Or at least there's NPT, but not NAT as in, as we know it from the IPv4 world. But there is. That's the thing. So it's like unfortunate turn of events, if you wish, but at the end of the day, I mean, from a pragmatic perspective, we have what we have, right?
Cool. Yeah. And the last quick comment: when you're saying when in the correlation section, you might actually want to mention NAT64, when you might actually correlate addresses from different address family even. So okay, Thank you very much. So, Diego.
Yeah, well, no, it's Diego Lopez. I just wanted to say that I'm glad to see what Fernando was presenting, because this is what has been one of the stories I've been telling to my colleagues working in IPv6 transitions and deployments, etc., is that we were lacking some kind of best practice documents regarding security. And some of the points that he has highlighted are part of the discussion. Just to support, I just wanted to stand up to support the idea, and that well, in the as long as my free bandwidth allows me, just to try to help in the process.
Just a quick comment. We did publish some operational security considerations for IPv6 some time ago. So yeah, if you have not, I suggest you might want to look at this. If you think it's missing something, we're definitely happy to get more documents in this group.
Is this practical approach about being a little bit more, how to say, didactical in the
Okay, Christopher.
Hey, Fernando. Thanks for the presentation. I had I guess a higher level question that I'm hoping you can clarify. So in section 3 of the draft, you talk about like different security practices that are implemented on the basis of IP addresses, like ACLs and blah, 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 other things. I'm wondering if you can elaborate on why those security policies are implemented. Like, what exactly are they protecting? And the reason I ask is because I'm wondering if, you know, implementing security policies on the basis of IP addresses is the right way to solve problems in practice, or if we should be perhaps looking higher up the stack to like provide meaningful security. There's this, as far as I'm aware, and I'm definitely not an IP expert or like a networking expert, I should say, or an expert in anything really, but the trend as I see it seems to be about like enforcing security policies using like more meaningful notions of identity, and that typically happens much higher up the stack, like at the application layer, for example. So while I think this like covers, you know, things that are done today, it's not clear to me if it's things we want to do moving forward, or if perhaps we should be solving these problems in like a fundamentally different way.
Well, my response to that is that you know, I would say that in general there's not like there's no silver bullet for that. So I don't think myself like, you know, like for example, if you think from the perspective of the concept of defense in depth, it's not one thing or the other. Let me give you an example of things that I do with systems that I admit myself, or I have something to do with those systems. I have ACLs to block like virtually all of the well-known scanners from the internet, like people like, or sites, not say people, sites like Shodan, Sensis, or whatever. If you ask me, well, do you think that's your security strategy? Certainly not. But if my systems were affected by whatever that is, I don't want them to show up directly on those, you know, search engines that are typically used by attackers to find targets. So that's not, I don't believe that it's like one thing or the other. Normally it's like you do a bunch of things in different areas. So it's not you use this and you don't do that. Actually, I think that like lots of different things are, you know, can, you know, complement each other. I wouldn't say that, you know, your strategy should be to block IP, you know, block things at that IP level and you're done. No, but for some things, they can be useful for some things.
Yeah, and I'm not saying that it's not useful. Like, don't get me wrong. What I guess I'm asking more generally or philosophically rather is like if there are different ways to solve this that are like perhaps just not using the IP address. And I understand, like, I like totally get the two examples that you just gave. Like, I don't want traffic from like some like particular cloud service or whatever, maybe it wants associated with Census or whatever other scanner that might be happening to like be continually hitting my service. I don't want that to have some effect on, you know, my service, like influence metrics in a particular way or whatever. I don't know. But the reason I ask this question is like I'm trying to, in my ideal world, and I welcome you to join my ideal world. It's crazy in my head, but limiting our reliance on IP addresses seems like the right direction to move in. And this work just seems like it further, encourages us to like ossify on the use of IP addresses. And I'll relinquish the mic, but like I hope that's sort of that's sort of clear, at least.
Yeah, one another example, just to give you another one, is like if you think about any of these smart devices that you might, assuming that you might want to connect them, that's a different question. If you really wanted to have those, but let's assume that you buy a smart bulb, these smart devices that you connect to the network. I'd probably block their access from the internet at the very least. Those are devices that I don't want to be accessible even at the application layer, because normally they are bad enough that probably the stack is broken already. So you don't need to get up to the app layer. So it's a tool. That's how I think about these things. It's a tool. Sometimes it's useful, sometimes it's not, but there are cases in which it's useful. I'm not saying that you should rely on this. There's also the thing that, normally when you say, and I agree with what you say, like, in my ideal world, now the issue is that normally when at companies all over the place, well, things fail. So you think that people have this thing, but for this reason or another, now it failed. And the only thing that you had was your simple and, less than optimal solution at times.
Got it. Thank you.
Yes, Arnaud today. So, in fact, thank you very much, Fernando, for this work. So, I have two streams of comments. So, the first one is to come back to support this work and to support what Diego said, and actually to perhaps complete your answer to Chris, because Chris, I would really like we have a discussion in your ideal world. I sincerely would like. I can understand your head is busy. My head is busy too. So let's try to see what we have in mind. I think what I would like to highlight here is the context of operational security. The context of operational security, just to remind people, I think 5 years ago, we were missing 2.1 million cybersecurity specialists. Today, the number is 3.4 million cybersecurity specialists. So the issue is that when you are facing what is the number one problem today, which is a ransomware, and you suddenly have a total panic because the teams are not prepared, are not aware, have not been doing the right things, and you are going to be exactly about to lose an entire business. And by losing an entire business, I have examples of companies that they managed to survive by one link. Otherwise, they would lose 30 years of business, something like 2 billion. I could give you these many examples. So the issue is not about where we go, it's now we have an urgency. And we need the right tools to be properly documented now. I would dream the world to be different, but that's not the reality. And so in this context, there are tons of things I could have added on what Fernando has added. I don't want to make this story too long. But I think it is very useful to have those documented, not in the idea to ossify, but to give a chance to people who are not aware, not trained. I mean, beyond that, the fundamental issue is not just we're missing 3.4 million people. It's today, the state of operational security is extremely bad. We have people who come vocationally to the job. There is the massive lack of curricular training and so on. So it's just to raise the gap between what we all would like to have, which is not even have all of these middle boxes. It should all be secure by design. That would be fantastic, but it's not the case. So for these reasons, I would like to support this work. The second thing has nothing to do with it. It has to do with, I've observed in ITUT, there is a technical report that is not about this exact topic, but I think it has some connection. It's not about IPv6, it's about SRv6, on a similar intention to document some operation issues. So maybe, I think there was a liaison statement that was sent from SG17 to IETF. And if we would establish this work item here, I think it would be good to reply that actually there is work going here. Maybe there are synergies to be done this way. So just to mention. Thank you.
Okay, thank you. We'll do the quick poll on the adoption, which will be confirmed on the list. So let me start it. Please actually raise your hand if you don't want to use on-site tool. Everyone using on-site tool, cool.
Kirsty Payne Splunk, just to say, if you're not registered in the on-site tool, please
Yes,
use
okay.
it.
Thank you very much for
so
the
that we have a
reminder.
good record.
Yes, so remember we used to have blue sheets. Now we have on-site tool instead. So if you don't want to sit on the floor next time because the room is too small, please use on-site tool. Okay, so I will end the session because I definitely see the interest in the room. Thank you, Fernanda. We'll issue the adoption call on the list. Okay, next presentation today is, and you shall preload the slides. Okay. Okay.
Hopefully this is working. Yeah. Good. Well, hi everyone. My name is Andrew Campling. I'm going to be talking about encrypted client hello deployment considerations, as it says on the slide. Picking up on a comment on the list just now on the chat. I apologize, I haven't used Comic Sans on the slide, so I'll take Warren's approach to be fabulous instead. You can be the judge.
It's not a requirement.
Whether I succeed. My co-authors, as you can see from the slide, Paul Vixie, David Wright, and Arno and Simon. Arno's in the room with me. Sadly, Simon recently passed away, but we're leaving him on the list of co-authors as he contributed quite a lot of content rather on enterprise security. Okay, so if we could move to the next slide, thank you. As a little bit of context for the document, RFC 8744, obviously from a little while ago now, looked at some of the issues and requirements for the encryption of SNI within TLS 1.3 and later. There's a sort of brief mention within it where the document characterizes unanticipated usage of SNI information. And it gives a brief assessment of some of the alternative options in the event that the SNI data is encrypted. And suggests that most of those unanticipated usage functions can probably be realized by other means. So the intent of the document that I'm talking about today is effectively to build on those comments in that RFC and actually document in a bit more depth some of those usages and by implication then document the likely operational impacts of the encryption of the SNI data within encrypted client hello. Which for those of you if you're not following closely the sort of TLS working group, that's pretty well advanced. I believe may well complete its journey possibly this calendar year. If that's wildly inaccurate, I suspect Chris would probably comment as one of the chairs, but who knows, but there or thereabouts, so within the next 12 months, probably, barring any surprises. So we think it's important and useful to make sure that the operational impacts are understood so that certainly the end user community can take appropriate action. Next slide, please. So as I say, ECH, when it encrypts the SNI and indeed other data, does have some operational implications for some use cases. Just echoing a discussion that we had in another place, it'd be important to say that it does have positive implications for many use cases. It would be incorrect to say that they're all negative, but there are some less positive implications, which certainly, if they're not understood, could have adverse operational impacts, and it's that latter group that we're focusing on within the draft. And within the document itself, thus far, we've really focused on the implications in private, edge, and public networks, and in particular looking at educational establishments, enterprises, and public network operators as three primary categories. We don't necessarily have to just concentrate exclusively on those, but those are the three which we have identified where there are significant impacts. We're open to anyone that wishes to suggest any expansion from there. The document itself is currently at version 05 and is on the data tracker, obviously, or is only reached version 05 on Monday this week, so I'm not expecting that necessarily you've all had a chance to read and absorb the latest draft, but it has already had quite a lot of impact from a range of different stakeholders, particularly those from sort of operational security, civil society, and in particular end user organizations. So for example, on the on the enterprise side, we've had quite a lot of input from CISOs on the large enterprises, where this is a topic where we've drawn it to their attention, is pretty high on their radar now. What we're not trying to do in the document is to identify sort of technical solutions specifically, and certainly, and I think it's important to state this explicitly, we're not questioning the wisdom of the development of ECH as an approach. Our working assumption is that that is and will happen. So it's just important to document the operational considerations on the security side for it. And I wanted to emphasize that because I think each time we've had this discussion, people have questioned whether the objective is to stop ECH. So it isn't, but it's important to make sure its impacts are understood. Next slide, please. Now, so in looking at some of the sort of documentation that's been sort of written to date around ECH, perhaps one of the things which seemed to be missing to us was an understanding that the SNI that's encapsulated by ECH is important and is of legitimate interest to on-path security actors. So they're not attackers in that sense. They do have a legitimate interest in accessing the SNI data. That's for things like malware detection, firewalls, etc. Stopping access to other risky traffic. Just picking up on the conversation we've just had on IPv6. And also there are other operational impacts beyond security as well, although we've spent less time looking at those. Next slide, please. I won't read through this in detail. This is just if you've not had a chance to look at the draft yet, this gives you a sense of the structure of the document as it currently stands, where we look at just some of the general considerations, then drill down into a little bit more depth into the educational sector, enterprises, public network operators, and then just tease out some of the general issues around things like threat detection, sort of network management, and so on. The document is by no means finished, and currently there's a section in there looking at potential future development of the work, and we've certainly got markers within the existing text where additional input is needed. And if you look on the GitHub, you'll see we've got sort of already a list of actions captured where further activity is also required. And I should say that obviously in addition to those things, there's an abstract and the other sort of mandatory requirements of an RFC. And it's an informational draft, which is the intent for it. Next slide, please. Again, I won't go in exhaustive detail, but just to give you a sense, I'll pull out maybe a few of these in the interest of time. Some of the end user impacts that we've seen looking at schools as an example, sort of use case. You may not know that in the UK and the US markets, schools have to operate content filtering. For example, in the UK, it's a mandatory requirement of schools to operate it, and it has to be effective. In the US, I think it's not technically true, it's a mandatory requirement, but if you're not operating content filtering, you can't access certain federal funding. So it's certainly an expectation, clearly. And much of the school content filtering software uses SNI to work as a functional requirement for that. So I'd also just comment that when you look at the operational capability of schools when it comes to things like IT, it's pretty limited. So moving to sort of enterprise type management capabilities is not a practical alternative in the school environment. You've got typically one person in, say, a UK secondary school or a sort of small to medium secondary school whose main task is doing things like getting the interactive whiteboards working, as well as just checking every so often that the content filtering works. They're by no means an expert in this sort of area, so it has to be fairly easy to use software. On the enterprise side, again, just briefly, so BYOD, bring your own device, often uses transparent proxies that needs SNI to work. Yes, there are certainly alternatives available for that, but ironically, they typically will require much more invasive software to be installed directly on the third-party devices, which isn't always practical if you're talking about devices being used by contractors and other third parties. So it adds to complexity. One of the big concerns from CISOs is compliance, sort of regulatory compliance obligations that they have, where they have to be able to guarantee that they're monitoring all inbound, outbound traffic, say in the finance sector. And again, you'll see in the draft, we've noted a recent example in the US where 10 banks are each being fined $200 million for lack of compliance because they weren't aware of certain interactions from some of their staff using banned software. So this is high priority. $200 million is a lot of money, even for a large bank. And when you get to the small and medium businesses, again, they just don't have the enterprise management capabilities of the large ones. They're mainly using off-the-shelf, often consumer software, so wouldn't be able to use the same tools. So anything that's more sophisticated than SNI becomes more of a challenge for them technically. Next slide, please. And then I think the public network content, at the moment we mainly focus more on the use of content blocking, whether it's a sort of legally mandated principally, but also some voluntary, where there tends to be a mixture of things used, but SNI is certainly a part of the mix that is used. And again, a bit like enterprises, there are often legal consequences, certainly in some markets, for operators that don't have effective filtering implemented. And I think this is certainly one of the areas where there's more work to be done on the content. Next slide, please. So finally, having looked at where will be a good fit for the draft within the IETF OPSEC seems like the right place, because it's looking at operational security challenges that need to be documented and understood. There's definitely an opportunity to contribute to the draft as it currently stands, and also just to scrutinize it, provide a comment on it. So really the question that we wanted to pose was whether there's agreement within the working group, and obviously by the chairs, that this would be an appropriate topic for the working group to adopt and then we can continue with the development of the draft. And I'll pause there for any questions in the available time. Thank you.
Yeah, we have 6 minutes, so please. I see people go into the mic.
Hi, Daniel Kahn-Gilmore, ACLU. So I am not a fan of mandated filtering regimes generally, as you probably are not surprised, given that I work for the ACLU. But I'm unaware of any filtering regimes that mandate the use of SNI filtering. And even the cases where there are mandatory filtering regimes, SNI is not a reliable signal. I can connect today to www.ietf.org and send it an SNI of ssl.cloud or sni.cloudflaressl.com, and it works fine. As far as I can tell, any SNI-based filtering regime would fail if they were trying to keep me from access to IETF.org.
Well, you're right, you can do that. However, two things. Firstly, most legislation I'm aware of doesn't mandate specific techniques.
As we hope it wouldn't.
Some of the legislation certainly specifies it has to be effective. Well, this is an important tool. If you look at much of the software, so I mean, Arno's better qualified than I to talk about some of the enterprise software, where it uses SNI, yes, it's known that you can fool it. So there are various techniques that are used first to make sure that it's reliable before it's used as a signal.
So as I understand, though, it is not reliable. And so if this is about operational considerations for people trying to comply with filtering mandates, it seems like this draft should talk about how the signals that they are currently relying on are unreliable. Not what happens when the signal goes away, but if the goal is operational considerations for people trying to comply with filtering, if this draft does not acknowledge that their current mechanisms are unreliable, then it's not doing them the service that I think you are aiming to do.
So the draft already acknowledges that it can be unreliable and talks about steps to validate. I mean, it's a bit like the conversation you had about IPv6. It's part of a defense in depth option. But again, Arno might want to interject because he's got more knowledge in this area. But
sorry, I mean, I made the same comment on the chat about the IPv6 defense in depth. Fernando's proposed approach to filtering his IoT devices to make sure that they don't do the wrong thing on its network by filtering them by IP address will fail if his IoT devices simply select different IP addresses. And so his filtering technique is not sufficient to keep the IoT devices from doing what he thinks that he doesn't want them to do. So it is not effective in the same way that SNI filtering is not effective.
So again, to be clear, and Arno come in a second, when we talk about use of SNI, it's in the context of understanding that there are weaknesses. It's not perfect, but it's part of an important mix. I mean, you'll be familiar with the indicators of compromise sort of document, which was sort of mentioned at the start. SNI is an important indicator of compromise. It's not the only one, but it's better to at least look at it than ignore it. So that's the view in the OPSEC world in any case. But Arno, please.
Yeah. So first of all, let's forget the SNI for a minute. There is nothing that is reliable on what we are doing at this stage. That's why some people started to create something called zero trust, right? So when we are in security, you cannot rely on anything. So SNI is just one of these elements, like plenty of others that can be fooled, that can be tricked, that can be changed. I mean, just think about email, for example, and others. So from a security, operational security point of view, there is nothing new here. The fact that we should not rely on the SNI, actually today, there are all the businesses in the world are using network security proxies to protect themselves using the SNI, because that's the only practical thing you can use today to actually do what you must do. So what the techniques that the proxies are doing, and I hope we can even document that in the development of this draft, is to explain how we start with the fact that we have to check if the SNI is correct at that moment. Most of the time, let's think statistically as well, most of the time it is. So we are using the SNI because this is how this has been built, and that's the last element we can use on network security to do on the enterprise side what is called selective decrypt. And selective decrypt is required to do what we call data loss prevention, and that is what is required. So if this is removed, how are we going to do that? I have no idea. But today, to come back on this work. So we have made in the GitHub that we hope, unfortunately, I could not open it for a stupid reason publicly, but we intend to open it as quickly as we can after this meeting. But we have documented that because that was the feedback we received from the side meeting in London. So we know we have to develop that. We're going to develop that text to show how it works, to give details about that. And we started to just make a placeholder at the moment, just to recognize we need to develop this part in the text. That's where we are on that.
Yeah, hey, Chris Wood. So I think DKG kind of summarized my concerns quite well. But I was hoping you could elaborate on these environments wherein it's insufficient to implement the same effect at the DNS, and you also need to do it based on the SNI. Like, what are those environments? And like, because that's kind of like the true measure of breakage of ECH. If you were to turn on ECH and it's used environments where you don't have like a filtering capability in the DNS layer and you are only using SNI, then yeah, like those people are going to have a bad day because like ECH takes that away. So I'm wondering like that seems like perhaps the important deployment environment to focus on. And if there's like any real like data or whatever that suggests how pervasive this particular deployment environment is, that would be quite useful. Because if at the end of the day, it's just if there's just two worlds let me take a step back. I kind of see like three worlds. There's like a world in which you can implement filtering at the DNS layer, in which case like just do that if that's what you're doing today. ECH has no effect on that. I have opinions on whether that's a good thing, but like you could just do it in DNS. The other world is like if you need to look at URLs to actually filter content, SNI is going to do nothing for you. Like you need to look at the URL. And a good example of this is like what Google has done recently by putting like all of their major applications behind like a single domain. Like Maps is now just like a URL behind like google.com. It's not maps.google.com. You also have things like connection coalescing that like, complicate the situation here a little bit. And then there's this third world that like I just don't think we have a lot of evidence really exists, wherein you can't do it the DNS, you can't man in the middle to do it at the URL layer, and you like are forced to do it at the SNI. And I don't have a good understanding of like how big that world is compared to the other two. And so like it seems like trying to, shed some more light on that is the right angle here.
Give a short answer. Sure. In the interest of time, Chris.
Yeah, very short, please. We are
Yeah,
like
I'm
2
sorry.
minutes over
I'm
time.
sorry.
And I closed the queue actually.
So short answer. We can have a longer conversation later. Because I think you raised that question when we had a call about a month ago. So we're now putting more text in on that specific point. But yeah, so noted, and we will come back with more detail on that.
Just quickly, is it like I think what's important is that like there's data to suggest that like it's a non-negligible amount of breakage, because that's like something to consider.
Yes.
And rather than just saying like there's an existence proof for this type of world to exist, like that doesn't seem sufficiently compelling.
Okay, Diego, please be brief. And
Daniel said what I was going to say.
Okay.
They are very similar. Both the IPv6 and this one. They are about.
Okay.
It's about illustrating those who are not savvy about this, and I think this is important for the group.
Okay, yeah. Sorry, Arnold, I closed the queue, so maybe we can bring this discussion to the list, because it looks like very useful discussion, but we unfortunately run out of time. So thank you very much, everyone. Thank you, our presenters, and hopefully see you in San Francisco. Let's discuss it on the list, right? Because I don't want to keep people in the room, and yeah.